All right, number 3, it also wants us to use long division, but I want to segue. I know synthetic is coming up, but I'm going to go ahead and start synthetic right here. So anytime you're dividing a polynomial by a linear term, especially a linear term that just has a whole number, I prefer to do synthetic division. You can use some algebraic methods, but I want you to kind of start seeing it here. So whatever your divisor is, you're going to set that equal to 0. We're going to find our box number. So that is x minus 5 equals 0. We would add 5 to both sides to get x by itself. And that gives us x equals 5. So the number that we're going to be working with is x equals 5. 5 is going to go in my little half box. Then I'm going to list the coefficients of my polynomial. So just like I did with synthetic or long division and listed placeholders, I'm going to do the same thing here. So my problem starts with an x to the third, which means I need an x to the second, x to the first, and then a term just constant. So I have an x to the third. I do not have an x to the second, so 0. I do not have an x to the first, 0. And then my constant term, negative 125. So these are going to be my coefficients. Number in front of here understood to be a 1, 1x to the third, 0, 0, 125. So I need a 1 here, 0 as a placeholder, 0, and then a negative 125. Keep in mind, we started with x to the third. Skip a little space, draw a line, bring the first term straight down. Below the line, you're going to multiply 5 times 1 is 5. Add with 0, you just get 5. 5 times 5 is 25. Add, we still just have 25. 5 times 25 is 125. Add these, we get 0. So this is your remainder. Okay. We don't have a remainder. These numbers are the coefficients of your remaining polynomial. So we started with x to the third. Okay, we're dividing by x, so we're going to reduce the power by 1. So now we're starting with x squared. So this means 1x squared is positive, so plus 5x, and then plus 25. So here's our resulting polynomial. With synthetic division, it's a lot faster. You don't have to deal with the variables until the end. Definitely prefer whenever you can use this method. So x squared plus 5x plus 25. Number 4, so we're seeing synthetic division. It just says consider the two polynomials. The result of synthetic division process is shown here. We're going to write the polynomial representing the dividend, divisor, quotient, and remainder. So the dividend is what we started with, this term up here. And we have constant term. So this is x, x squared, x to the third. This looks like an x to the fourth problem. So we're going to start 3x to the fourth minus 14x to the third, and then minus 7x squared, and then plus 16x, and then it'd be minus 28. So you just kind of count those terms, and that lets you know what power you are. So here's our original dividend. The divisor. So since we have a 5 in the box, remember how we worked backwards. So usually I would start out, okay, whatever's in the box, x equals 5, and then work backwards to get it equal to 0. So you would subtract 5. So this term is our divisor, x minus 5. The quotient, so once they divided, this remaining polynomial is the quotient, the answer that we ended up with. So we're not going to write the remainder part, we're just writing the quotient part. So we started with a 4th degree. We divided by 1x right here. So we're going to start with a 3rd degree. So this is going to be 3x to the 3rd. It's going to be my first term, 3x to the 3rd. And then it's going to be plus 1x squared, or just x squared. And just count down by 1 each time. So the next one is a minus 2x, and then plus 6. So all of those numbers are just coming from right here. These are our coefficients for the polynomial here. Alright, and then it says the remainder. So the remainder is what we get at the end. So 2 is our remainder this time.